Hello, welcome back. I'm glad you're here for the second part of lesson 4.5. We're still talking about averaging or setting the best measure of center of data. But now we're going to talk about a special kind of data. It's called grouped data. And remember back in lesson 4.4, we had some group data on the high temperatures for each state. And we created this frequency distribution here. We had these classes of temperatures, and then we counted how many of each state fell in those temperatures. So we are going to find what's called the grouped mean, or mean for grouped data. So it says the strategy is based on this idea. If we have a grouped frequency distribution and don't know all of the exact values, it's impossible to add up all of the values. Instead, we'll find the midpoint for each class and estimate that all of the values in the group in that group would likely average to that midpoint. And then in this case, by average, we mean mean. So if we multiply the number of values in the class by its midpoint, we're estimating the sum of all values in that class. So the way they find their midpoint is a little bit different than how we would do it in our stats class, but they average the 100 and the 104. So the midpoint for this data would be 102. And that comes from 100 plus 104 divided by 2 is 102. So you're averaging the lower and the upper. And then the next one would be 107. And then the next one would be 112. And you can see that the lowers are all 5 apart. That was the width. And that means the uppers are all going to be 5 apart as well. And then that also means, that's the cool thing, our midpoints are going to be 5 apart. So we could just add 5 to get to the next one, which will be 117. And then 122, and then 127, and then 132. And so down below, it shows you how we multiplied them. So we multiplied the frequency for the first class times its midpoint, plus the frequency for the second class times its midpoint, and so on. And then added those up and divided by the count. Now you might think the count would be the number of groups, 1, 2, 3, 4, 5, 6, 7, but it's really the total number of states. And there were 50 states that we collected the high temperatures for. So our multipliers all multiplied and then added to 5,715 divided by 50. So the average temperature would be 114.3 degrees. Now this is an approximate mean because we didn't have the exact data. We only had the midpoints, right, to base the data from. So I want to show you in Desmos how you can do this. Okay, so in Desmos, I put the midpoints in X1, that's the key, and then I put my frequencies in X2. And then I made a second column similar to what we did back in Unit 2 when we were doing some multiplying columns. I said multiply column 1 times column 2, and it did that for me. And then down below, I can say total up the X1 times Y1 column, my multiplied values, and then divide by the total that are in Y1. Okay, that would be my total count, my total frequencies. And that came out to be 114.2. So if you turn your into your workbook to page 455, it goes through how to find the midpoint. Find the mean for the grouped data. So we went through and did this. We found the midpoint of each class in the group. We multiplied the frequency for each class by the midpoint. We added up all of the products from step 2. And we divided by the sum of all the frequencies. Number 1 here says, explain why this formula only gives an approximation to the mean, not the actual mean. And that's because we are not using the actual data values. We're using midpoints to represent them. Okay, let's try another one. So the group frequency distribution provided illustrates the selling prices of the 95 homes most recently sold in my town. Find the mean selling price. So we need to have a midpoint column, and I'm going to do that over here because I like to have the midpoints on the left because that's what we usually put in as X1 in Desmos, and then we put our frequency as Y1. So I'm going to take in my calculator and I'm going to add 101,000 plus 200,000 and divide by 2. And I get my midpoint of 150,500. Then I'm going to add the next two and get the mean and get 250,500. And then you can see these are all 100,000 away in the lower bounds. And so my midpoints are going to be 100,000 away. So this should be 350,500. Then we can go to Desmos and go ahead and put in your X1 values and your Y1 values, and we can calculate those. And I will share my Desmos with you all as well, where I'm sharing the video from today. And so let's go ahead and put these in here. So I'm going to put a note so I know that it's down below. So this is the selling prices of homes. See data below. Okay, so let's make a table. And so I'm going to put my midpoints. And then I'm going to put my frequency in Y2. And these are in X1 and Y2, X2 and Y2. So I have to remember that when I do when I tell Desmos what to do, I have to make sure that I also tell it that it's in X2 and Y2. 64, 26, and 5. Okay. So now total X2 star Y2. Oops, Y2. Now, I didn't even have to make that multiply column like I did up above, because if you just say total, when total up, when you multiply X2 and Y2, it will do that for you. And then you can just say divide by the total of Y2. And so the mean selling price is 188,394 and 74 cents. And I will show you my paper. Right here, the mean selling price is $188,394.74. Next topic, college course grades. So it says many college courses have a grading system where different course activities make different contributions to the final grade. The idea is that things like tests typically have a bigger effect on a grade than attendance. Here's an example from a course I taught recently. So it says homework average was 50 points, 4 tests were 30 points each. Final exam was 50 points. The group project was 20 points, and the attendance and participation was 10 points. Now, he does this a little bit different than I do. I like to add up to 100, but these actually add up to 110. Excuse me. Let's turn the page. So the size of the relative contribution for each activity is typically called a weight, and the overall grade is called a weighted mean. It turns out that we can calculate the weighted mean using the same steps we use to calculate the mean for groups data. We just have to do some interpretation. So it says Tong is a student in a class using the grade structure just described. Her scores for each portion of the course are listed below. Homework average, the 4 test scores, the final exam, the group project, and the attendance. So if you were going to use a procedure for finding the mean for group data to calculate her overall grade, what role is played by the weights for each portion and what role is played by her scores? Okay. So the solution by the author says, in my view, the key to understand this is points. Think of every single point in the course as one occurrence of something being awarded. When you see that when you see that homework counts for 50 points, you can think of it as 50 times that a point was awarded, which makes it feel a lot like a frequency. So the fact that Tong has 87% homework average is like getting 87% of a 50-point different times. If that makes sense, then you get it. The bottom line, the weights act like frequencies in a grouped frequency distribution, and the scores for each portion act like the points of the class. Okay, so in Desmos, our X1 and Y1, we're going to put these in. So it says the weights act like the frequencies. So in a group frequency distribution, and the scores for each portion act like the midpoints. So our score for the homework would be 87 here, and you can leave it as the percent. You don't have to turn it to a decimal. And then the homework average, they said, was 50 points. Okay. And then we'll go and put these, we would list 91, 82, 86, 84. We're going to list them all in Desmos. And he said the test scores were 30 points each. So they didn't total 110 because I didn't take into account that there were 4 tests. So there would have been 90 more points. So there's really 200 points to be earned in this class. These were each 30. Okay. So I kind of think of it like this when I explain things to students too, that you're earning a percentage of each of these points. You're earning 91% of these 30 points. You're earning 82% of this 30 points. So let's go put it in Desmos and see if we can make some sense out of it. So down here, I'm going to make a note of what's below. So this is the grade data from workbook page 456. Okay, so let's go ahead and start our table. And I'm going to put all the scores. So I'm going to do the homework average, the 4 test scores, the final exam score, the group project, and then 100% for attendance. And then the homework average was 50 points. Each test was 30. The final was 50. The group project was 20 points and attendance was worth 10. So number 3 on page 456 says, use the results of the school example 2 and the mean for group data to find Tong's average for the course. So that's what we're going to do. So we're going to say total of, and then this is x3 times y3 divided, divided by the total of y3. So I'm going to write that for you all to see so that you can see on my paper here. So Tong's average in the course would be an 88.72%. Save this. And go back to my paper so you can see what I wrote down to share with everyone. So this is how we would type it in Desmos. Remember, you're going to be using your columns. And that is her score. Okay. So page 457, it says, what are the pros and cons of each of the measures of average we studied? So there was the mean, the median, the mode, and the weighted mean. If you turn to page 459 in your course pack, they actually summarized each of them for us. So the mean is unique. There's exactly one mean for any data set. It factors in all of the values in the data set. It's easy to understand. The median, the weakness of the mean over here is it can be adversely affected by a few unusually high or low values and can be time consuming to calculate for large data sets. Now for the median divides the data set neatly into two groups, the lower half and the top half. It's not affected by one or two extreme values. That's a good thing. The weakness is it can ignore the effects of large or small values, even if they are important to consider. The mode, super easy to find. It describes the most typical case. It can be used with categorical data, which is nice, but it may not exist for a data that has many, many different possible outcomes that are different from each other. It may not be unique and can be very different from mean and median if the most typical case happens to be near the lower high end of the range. The mid-range is very quick and easy to compute, similar to the mode. Very quick and easy to, provides a simple look at average. It's dramatically affected by extremely high or low values in the data set, and it ignores all but two values in the data set. It only uses the lowest and the highest. The mode in the mid-range, you're going to have to calculate by hand using a calculator, but you'd have to actually do that. The mean and the median can be found in Desmos. Okay. Okay. Then question number 5 says, this is my favorite question in the whole lesson. Look back at the description of the average college student, which we kind of did. And it says, for each characteristic listed, right, which measure of average you think was used? So the average age, I would say the typical age was probably the mean. Where do you live? Most likely would be maybe the mode. It's categorical data. Do you work? How many hours do you work? And that could be probably the mean. And gender most likely would be the mode, because again, it's categorical data. The number of hours you sleep down here is going to be the mean, probably. Family income, they probably would have used maybe a weighted mean because it might be like grouped data, maybe mean or weighted mean. Credit card debt and school debt, probably mean or weighted mean would be my guess. And that wraps up everything so far for this lesson. Catch me back for lesson 4-6.